Hello everyone. Let's talk about inverses again, but this time let's talk about how to find an inverse algebraically. So for example, if we have f of x given and it's equal to 2 over 3, mean 3 over 2, x minus 6, and we need to find the inverse, f negative 1 of x, right? Inverse. Well, what we need to remember is that we get inverse by making y and x change in place. So first step to do would be just to, instead of f of x notation, just put y, just to make it easier on ourselves, I guess. And now to obtain an inverse, we need to make x and y change places. So what was y becomes x, and then what was x becomes y, y1. Now this is already an inverse, but we usually need to solve for y. So let's solve for y. So first step would be to add 6 on both sides. We add 6. So left hand side is going to be x plus 6, and the right hand side is going to be 3 halves y. This multiplication. Now next step could be multiply by 2, divide by 3. But we could also just do this. We multiply the whole thing, both sides, by the reciprocal, 2 over 3, right? Like this, 2 over 3. Now what happens here is these 3's divide, these 2's divide, so we really get y to be by itself, and I'll move it to the left hand side. And then here we will have 2 over 3 times x plus 6. And that is our inverse. Now let's just use the inverse notation. So f little negative 1 on top of x equals to 2 over 3 x plus 6. Now just to make it easier to graph, I'm going to distribute actually 2 over 3. So this is going to be 2 over 3 x, and then plus 6 divided by 3 is 2 times 2 is 4. So this is just plus 4, right? Or you could say 6 times 2 is 12 divided by 3 is 4. So now we have our slope, we have the intercept, and we can graph the inverse. I want to graph the inverse just to show or check will they actually reflect over this y equals x line, 45-degree line, because that's what inverse should do. If we have the original right there, and then we graph it, and then we graph the inverse, two of them should look like they're reflections of each other over this y equals x line. So let's graph. Let's say we graph the original first. And I'm going to, I guess I didn't pick the best colors for this because they're real similar. But I hope you can see it. So the original has the intercept, y-intercept at negative 6, and then has a slope of 3 over 2. So let's find the negative 6. 1, 2, 3, 4, 5, 6, negative 6, right? And then, so graph is going to go to this point, and then slope is 3 over 2. So 1, 2, 3 up, 1, 2 to the right, and then we can repeat that again if we want to, right? So our function is going to look something like this. And it's going to hit the green line somewhere over here, right? Okay. And then So it goes through here. Right? Now if we do the inverse, and I'm going to do it in red, so the inverse is going to be in red. So now we have y-intercept is at 4, so 0, 4, so 1, 2, 3, 4. So we know the function is going to go through that. And then the slope is 2 over 3, so 2 up, and then 3 over, 1, 2, 3 over. So the function is going to go somewhere this way, right? Oops. I didn't do the best job here. But you see what I'm doing here, right? Actually, let me just... Oops. Didn't mean to delete the whole thing. Like that. And then like that. Okay. Not really much better, but that's okay. So this is our inverse. So this is f inverse of x. And then the blue one is the original. So this here is our f of x. Now we should be able to see that they look like they're reflections of each other, right? Over this y equals x line. And they should be. They should also cross each other at the place where they cross the 45-degree line. That's always the case. So whenever the original hits the 45-degree line, that's the same place where the inverse is going to hit that same line, right? And then if you would check, this here is 1, 2, 3, 4, so this is 0, 4. This one here would be 4, 0, right? This one, 1, 2, 3, 4, 5, 6, so this is 0, negative 6. This one would be negative 6, 0, right? So all of those are actually reflecting, right? This one kind of reflects on itself, right? So how do we find the inverse algebraically? Well, if we have f of x notation, it's a good idea to change it to actually y. And then after that, we make y and x change places. So what was y becomes x, what was x becomes y. And then we simply just solve for that new y. So here it is. To check, we can graph, or just for the fun of it, we can graph and see how the red one, the inverse, and the blue one, the original, they are reflections of each other over this green line, which is y equals x line. And that's the line that inverses should always reflect over. Thank you for watching. Make sure you like and subscribe, and always don't forget to smile. Thank you.